Welcome to Brain Vision.
Part A of this problem is asking what the total elapsed time of the slower rock will be on its entire journey. Before we're able to calculate that, we need to figure out what the initial velocity of the slower rock is along its journey. And so we're given this information. The acceleration is negative 9.8, the initial position is 0, the initial speed of, or the initial velocity of the slow rock is just the initial velocity of the slow rock, and then of the large rock is 3 times the slow rock. And then the time elapsed for the faster rock is 10 seconds. So since the time elapsed for the total trip is 10 seconds, we know that it takes 5 seconds for the fast rock to reach peak height. And then once it does reach peak height, our velocity will be 0. And this is velocity of 2, which I call the faster rock. Now, in order to figure out the initial velocity, I'm going to use this kinematic equation. V is equal to V naught plus acceleration times time. V at the peak is 0. Our initial velocity is, this is of the fast rock, by the way, so V naught 2, which is 3 V naught 1 plus the acceleration, negative 9.8, times the time. And this is the time from the start until it reaches peak height, which is 5 seconds. We can solve this for the initial velocity of the slower rock. We get 16.33 meters per second. Now that we have this, we can figure out the total time for the smaller rock. So if V01 is equal to 16.33 meters per second, we can use the same kinematic equation. V is equal to V naught plus AT. The difference is before I applied it to the faster rock in order to find this, but now I'm going to apply it to the slower rock now that we know this. And because we're applying it to the slower rock, I got to remember to put that subscript there, the 1 there. And so we're just going to go up to the peak. So the final velocity is 0. This is 16.33. Acceleration is still negative 9.8. And then t. Solving, we get t is equal to 1.67 seconds. That is just the time it takes to go from the beginning until the top of the height there. So we have to double this to get the total time elapsed. So t total of the slow one, number 1, is double that, or 3.33 seconds. And that's the answer to part A. We also need to figure out the relative heights that these travel. And so that is part B. So to do this, I'm going to figure out the total height that the faster rock travels, and I'm going to figure out the total height that the slower rock travels, and I'm going to divide them to figure out how the ratio of the two acts, which will give me the final answer. So V naught 2 is 3 V naught 1, and we calculated V naught 1 before, and it's 16.33 meters per second. So this ends up being 48.99 meters per second. Again, I'm going to let the final velocity be 0. We're just going to go to the apex. And then the time elapsed for this is given in the problem, and it's 5 seconds. And so I'm going to use the kinematic equation that relates these quantities. X minus x naught equals 1/2. And then I'm going to plug in my velocity. Really, it's the difference of the final and the initial, but in this case, the initial velocity is 0. So I just have the final velocity of 48.99 times the time elapsed, which is 5 seconds. This gives a distance traveled of 122.5 meters. Now I'm going to do the same thing for the slower rock. Use the same equation. X minus x naught is equal to 1/2. In this case, the initial velocity is 16 because it's a slower rock. And then the time elapsed until it reaches the apex is 1.67 seconds. So doing this out, I get x minus x naught is equal to 13.64 meters. So really, they called this h, and they want to know what this is in terms of h. So to do that, we divide the two. I'm going to denote the distance of the faster rock by putting a 2 there. And it's 122.5 meters, but I want to divide by what the slower rock is going to, which is 13.64, and I'm going to call that h in the units there. Doing this out, I get that's approximately 9h. So if h is the height that the slower rock goes, then the faster rock goes 9 times h, so 9 times as high. And that's the final answer to part B.